nose faces the rear. And next thing we're going to do is resheet the running boards. The Studebaker Speedo, which used to go up in here, obviously will not work anymore. We're rolling. We wish we were rolling here. That's what this is all about, rolling big. So building a car like this, either for money or for sport, this is arduous and painful, but it is sport, is about making something unusual. I just had this notion about doing a really special hot rod, something a little off the beaten path, twin rear engines. So,
hold on, let me intro.
That's how it always starts. Somebody you start and then you interrupt. This is like the Dickie Smothers show. Yeah, so in any event, so Power Brake Bob, you asked me what year was my funny car. My funny car was an '89
Wait a minute.
T-Bird.
Let me intro it first. Right?
Sure.
Yeah, let's intro it first, and then you can talk all you want.
Oh, I forgot we're syndicated.
Yes.
Okay, go right ahead.
This is a 47 Studebaker, which has been modified, and it is equipped with 3 LS1 engines in the bed. And we thought this was a perfect candidate for our air brake system. The air brakes are fantastic in that they have all the stopping power you want. The air hydraulic booster is mounted remotely. We just have an air valve on the foot pedal and a parking brake valve that will set all 4 brakes when the parking brake's set. So the entire vehicle is unique, and we thought it was perfect for the air brakes. And our friend Dick Wagner here is going to tell us all about his dream and his, what is this, the 4th project or 10th project in your line?
Well, you don't want to rush into these things.
Well,
the T-Bird's 22 years. This is since '05, so we're entering the 7th year on this project. This has 1,050 cubic inches, about 400 horsepower per motor, so 1,200 horsepower in stock trim, probably a half a ton of torque, and should be a real simple, easy street 24-cylinder driver, because it's being timed not as 3 8-cylinder motors firing simultaneously, but as 3 independent motors timed to produce a single symmetrical 24-cylinder motor. That is, every cylinder will fire at 30 degrees to the prior cylinder.
Idles like grandma's car.
Yes.
It'll stand on the rear tires anytime you want.
Yeah, well, it's 3 grandma cars in one. Very powerful grandma cars, but so it's basically like 3 Corvettes in the back. But you know, many people now have created 800,000-900,000 horsepower street cars. That's, you know, I mean, I wouldn't say there are 5,000 of them, but there are probably several hundred in the United States, if not more, cars of that type. I'm one of them. I'm an 800 horsepower T-Bird right over here, which you've probably seen if you've watched the YouTube video on how the Hydro Boost was put in. In any event, this car doesn't need to be as radical even as the T-Bird to make 1,200 horsepower. It's going to idle like Grammy's car, because it is Grammy's car. You know. So the trick here is taking 3 super light LS1 motors weighing under 400 pounds apiece, 375 pounds, making more than a horsepower per pound, and all aluminum, and producing ludicrous torque, ludicrous horsepower, all at whisper idle. Easy.
Well, it's going to have a nice throaty exhaust to it, because we're going to have headers and short mufflers, so it'll rumble.
It will, but it'll be a butter. It'll drive. It should really drive like butter. It's a 139-inch wheelbase, so it's going to ride nicely. That's about 2 feet longer than it was. It's a nice long limousine sedan type of ride with a bit of horsepower and quite a bit of brakes.
Absolutely.
air brakes. When I turned 50, I had not been to a racetrack in 30 years. And I went out to the Winter Nationals, or not the Winter Nationals, at that time, the Winston Finals. No longer involved in drag racing, is Winston. But that was called the Winston Finals in November of around 1993. And I heard these nitro cars just shaking the place. Car alarms going off. The bleachers sounded like they're going to come down. Sounded like two jet planes taking off. I mean, it was so different than when I had gone to Lyons Drag Strip in the 60s and 70s. And way back then, you know, way different. And so I was just hooked. So in 94, I turned 50, June of 94. And in January of 94, we had the Northridge earthquake, which beat up a lot of houses. Gave me a bit of work for a couple of years, not as lucrative as one would think. And I also got a settlement of 93 grand for damage to my own house, which was gravy for me because I could do all the work and fix it. So I did, and it allowed me to buy a funny car and go funny car racing. What a way back into drag racing. So from 18 years old, 94 miles an hour, 14 seconds, to 50 years old, 183 miles an hour in 7 seconds. I got into building some cars again, and so in 92, in 89 I bought the T-Bird. I've worked on that, and V8'd that car. We'll talk about it. And about almost 7 years ago, I found this car and began working on this car. And in between I'd had a Hollywood Graham and an old Studi and a big block 396 Chevy supercharged motor and a Gremlin, you know. Had a Dodge 426 Dick Landy Hemi Dodge. I had some nice cars once I got back and did the G-Force bug, you know. And you have the G gene you must express, and I needed acceleration, so funny car and all these cars. But anyway, so we got to the point of having too many cars, and I got rid of most of them, and I'm down to the T-Bird, the truck, and this car, this 47 Studi. It used to be an M5 pickup, now is lower, longer, wider, faster. So now it's a nice looking. It's had a severe facelift and body lift. Some of the modifications of this truck include suiciding the doors, that is, opening from the rear. Kind of cool. Thought it might make it easier to get in and out. We'll see. A lot of work. We've also gapped the doors in steel, not Bondo. So when this is finally done, this gap will show itself as a very tight reveal, 1/8 of an inch. Also made the bed tilt up and the front tilt. Very strong. They push up about 30 inches long, extend another 2 feet or so, and these push up with about 300 pounds of force each. It's a pretty heavy bed, so that kind of force is justified. You can also see a little bit more of the alignment of the engines. The engines are covered so that they do not get molested by spray paint and other things. Now, the fact is that there have been twin engine pickups in the past. Somebody has done this. But I wanted to make them over 1,000 cubic inches. 2 engines totaling 1,000 cubic inches. So I could call it the Kilo Cube. Kiloku 3 overline B. And I was going to do it with big block Chevy or Mercruiser GM Marine engines or something like that. What ended up happening was I bought many engines for this. I bought this truck for $1,100 delivered. It had a Buick V6, a Chevy 350 Transvol's rear end, a Mustang brake pedal hanging in it, not hooked up, a hot rod that never got worked on after 1979. And so, short story is I bought a Buick Grand National super turbocharged motor, Then I bought a complete Mustang down the street, $600, a complete 86 GT or 88 GT convertible, beautiful. I was just going to put everything Mustang in this truck. And then I had another change of mind, and I bought an 800 horsepower big block 454 engine from my buddy Randy. I said, okay, I really like to do the twin engine thing. He says, well, you got to duplicate the motor you just bought then. You can't have two dissimilar motors. I said, oh, man, oh, shit. So I'd already bought 3 motors, okay? So I buy, I get on eBay, and I find 2 5.0 Turbo Cruiser motors in Missouri for $8,300. I buy them, the guy screws me, I never get the motors. That's now 5 motors. I still wanted to do the big block deal, so big block Chevy motors. So I talked to a buddy of mine at Vortec, Bob Endress, and he said a friend of his just had 50 delivered to him from GM. This kid had bought 50 5.0 motors, like $4,000 a piece. And he says, Bob has a funny voice. He talks kind of like this. It's this kind of funny thing. And he says, hey man, these are great motors, man. They're like 375 pounds, and we listen to Porsche, 6, and on and on and on. He goes, pound per horsepower, And I said, that's all great, but these are 350 cubic inch motors, 5.7 liters. I want 1,000 cubic inches. I need 3 of them to get over 1,000 cubic inches. That's the theme of the car. And then I thought, what the F? You want to be different. You want to do something exciting. Nobody's done 3 engines in a street car ever. I mean, tractor pullers, yeah, but not like this. I ended up taking the car apart, having the panel, the body soda blasted, took the frame next door to another place, had them box the frame and do all sorts of stuff, put in suspension, put in my rear end for Mark Williams, and so here we have a nice $7,000 Mark Williams 96,000 series, funny car rated, that's what it's for, 430 gear, Detroit locker rear end. And this stuff, this is called a 4-link suspension, and this part was done by Scott's Hot Rods, as was the coil over front suspension. So this is what's going to take all this 1,200 horsepower and put it to the ground through these 18-inch wide Mickey Thompson tires, and through a beefed up frame. The frame needs more beefing. It's a kind of a nice design with these round cross members and such, but it needs way more beefing, because once these motors hook up on those tires, it's going to twist this thing like a pretzel. So we have to
power brake Bob's opinion.
Yeah, and so to that end, we've rigid mounted the motors. We're going to put additional struts per power brake Bob's recommendations, and already pre-designed by me to begin with, up here, so the engines don't try to twist the frame so much. We're going to run, after we run exhaust through here, we're going to run hopefully some stands out there on these motors. We're trying to get weight forward because all the engines here, there's 3 engines. These are GTO 2002 LS1 motors, brand new, 400 horsepower stock form. Computer controlled, electronically, managed, fuel injection, real easy. All 3 will be tied together right at this junction. What you see here is the back of a crankshaft, an adapter, an aluminum adapter, a CV joint, it's like a U-joint with ball bearings, and then the inverse over here to a damper on this next motor. This has all been special made, and this gets connected with a little short piece of 1.25 inch diameter 28 spline axle shaft about 9 inches long. Then it'll be covered by a decorative dust boot. Also keeps the oil from splattering. We have 3 engines. The nose faces the rear. The front end is the back of the car. That's where the transfer case comes in, turns the power, and puts it back to the rear end. To connect these motors, we're using adapter plate, CV, and an axle between. They'll be direct drive. One through the other, through the other. Time 30 degrees off, as explained before, to make it a true 24-cylinder engine. The exhaust right now is planned to be done by Gibson in Corona, And this may entail bringing all three engines together into one pipe here and coming back with a muffler in the space in here. There's also the possibility of running them under the motor, just one next to the other, and doing it with 6 mufflers. These motors are kind of interesting in that you can actually turn both the exhaust manifolds backwards, and you can turn the injection end for end. So as it turns out, we're going to run them in the standard normal injector at the front position. That works for us in this. And make a single 8-foot long valve cover that will unify these motors and give it more of that locomotive Allison diesel look.
Allison.
As it's a huge single motor. So the front of the second and the third motors had to be treated to receive power from the motor in front of it. The existing balancer on these motors was just pressed on with a bolt. It's a piece similar to this, but if you'll notice, this one has a slot in it called a keyway, and a piece of metal is driven into a corresponding mirror image of the slot in the front of the crankshaft. So the crankshaft comes through here with its own groove, and a piece of metal is driven in there. That prevents this from ever rotating. The balancer on the front of the LS1 motor doesn't have any bolt holes like this or any of that stuff, so it could not receive any kind of an adapter, this, to mate it to this area. So we went to ATI and had special balancers made with double keyways, so that not only is there one keyway, but there's another one here. And we had to take the crankshafts out of these two motors and have them double keywayed. And then there was some issues with that, and eventually we got ATI and the cranks to agree with each other, and so now we have these ATI balancers which are made to receive blower pulleys or other drives off the front, and we're using our adapters and our CV joints into that part of the system. On the back side of the motor, none of this was necessary. All we did is remove the flywheel, make an adapter, bolt our CV joint on, and we're good to go. The first two connect in exactly the same way. 1, 2, 3. The third motor bolts in standard fashion to a transmission. A single starter mounted here, a 2 horsepower, what's called a high torque starter, made by High Torque, goes here. These are modified forklift starters that have enormous cranking power. And this one starter is a 2 horsepower unit, and it will turn all 3 motors simultaneously. We hope. The cooling for this is going to be provided by radiators, which will go along the edge of the bed at the top, between the bed and here. And I'll drop it down now and I'll show you how that's going to work. This is a temporary control. This will be mounted in the console. Everything attached to the engine can be no wider than this, and everything attached to this can obviously be no wider than this. So there's about a 10-inch space here, and about 100 inches, a little over 8 feet, from here to the front. So I'm going to use radiators, approximately 10 by 30 inches, 3 of them, on each side. They'll all be connected through each other, and they will provide the cooling for 3 engines. There'll be a bank of fans below these. You won't see them because they'll be below the radiators, but the radiators are going to be about right here. And so you'll still be able to see past the radiators. You'll see the wiring, the headers, and things like that. But there'll be this rather industrial-looking grid here on each side. Each motor will have a different accessory. One will carry a pretty huge alternator, perhaps 220 amps. air conditioning compressor, a power steering pump for the power steering, and an air compressor for the brakes and the lift system. And those will be spread across these motors, provided by Power Brake Bob, hopefully. The brakes, certainly. We're excited about the air brake system. It's going to provide stopping power for clearly a lot of go power. And with this kind of go power, you need big whoa power. The brakes themselves are, I think, 11.5-inch dual disc, a dual rotor, drilled, slotted, Willwood with Mark Williams calipers and Power Brake Service air system and lines. So we should have really, really good clamping power on this very fast truck. The wheels and tires on this truck are made by Centerline. They're called Convo Pros. Side rims, 9.5-inch tires. The rears are 15-inch wide rims with 18-inch wide tires. I intentionally went to a very fat front tire to make this not look like some little skinny tired race truck. This is a beast. The front tilts electrically. These are electric life, L-I-F-E, screw jacks, if you will. And this was the original intent, to use these type of devices to open the front and rear. Turned out it was easier to use these for the front and then obviously the air for the rear. And next thing we're going to do is resheet the running boards and continue working on the front end. You see all sorts of cuts and patches and pieces pushed in to clear this fender. And so we have a little work left to do there, but we've done a tremendous amount of work around the edges, making a hard edge, cleaning up the underside, a little more bracing. We've built a tow bar at the front, detachable, just 4 bolts. That'll help in showcasing the car. The transfer case will sit between the wheels on that cross member. And we're ready to start going battery tray, transfer case, and if we can get some sponsors, electronics. The weight up there will be a good thing because this is going to want to lift the front tires when you hit the gas. So working back from the rear of the car to the front of the car, this is about 10.5 feet from here to what will be a transfer case up over the front cross member. That requires a 2-piece drive shaft. You don't want a drive shaft longer than 5 feet. 4-inch diameter, series 1350 or 1480 monster U-joints, steel drive shafts. And then they'll be joined in the middle. The 2-piece drive shaft will meet about here. Then just forward of that, we see the fuel tanks mocked up in foam, about 35 or 6 gallons between the two of them. Cut out to provide access to the transmission pan. This is a mock-up. This is just the case of a 4L80E transmission. Probably won't use this identical one, but more likely a Power Glide, beef Power Glide, which I have, and therefore less expensive. So, and from this point, the drive shaft will go into a transfer case that basically takes the power from the engines and runs them back this way. So we have an upper drive shaft, a transfer case, 2 lower drive shafts, several U-joints. And then up front we have Scott's hot rods, show quality. It will look at when we get done. Coil over, what's called coil over, meaning a coil around a shock absorber. Independent A-arm tubular chromed front suspension. Mostly stainless steel here, but chrome there, I think. And you know, probably 3-4 inches of travel, not huge, but you know, a comfortable ride. And then power rack and pinion steering here, and from up above with the hood assembly open, and from in the car you'd be able to see the circuitous route one must take to get this steering arm up to a steering wheel inside. 4 U-joints and several supports and all that. The interior is obviously going to be a couple of bucket seats, air conditioned. We're going to use an old air system at this point. It's a brand name. And we've gone back to the old dash piece right here. This is necessitated now. I've got to move the steering column back about 3 or 4 inches because before we were going to do a flat dash. Now we're not. And then where the old radio used to sit, we're going to take that part of the dash off, and we're going to make that a 12-inch plasma screen, touch screen for all the electronics. So that'll be the tuner, the controller, the preamp, everything. So given that we're going back to some of the stock dash, the Studebaker Speedo, which used to go up in here, obviously will not work anymore. So from here across to the other side, about 2 feet, leaves room for perhaps 10 gauges. We're hoping to use VDO, slant bevel front gauges, red lit, in just a straight line across there, gradually turning towards the driver. There's been a lot of metal work done on the car. Clearly, I mean, as you see here, the gapping and all that. Running boards are pretty long. Pretty arty piece. Doesn't look it, but it's quite the deal. Our gaps are very, very tight. Gaps on the whole truck will be 1/8 inch. That's impressive. The front end is, you know, almost a dozen pieces of metal at this point. If you look at the inside seams, you can look at the outside as well, but you can see where pieces have been joined together. So we've got 2 outer fender pieces, 2 inner fenders, 2 dart pieces we call them, and then this hood has been cut, pinched, slid again, widened. I mean, there's a dozen or more different pieces of metal that have been cut and modified and put back together. Patch panels, headlight openings, the subframe around the grille, that's been doubled up. These have all been modified. And there's still a bit more to do, but this is getting close to its finished product. So we decided on a late model VW headlight. I do like the lens, so I think what we're going to do, we were going to tilt them up a little more vertically. There it is at that rate. But the fact is, we thought that the headlight was really going to sit about like this, and there would be this metal taper behind it. So we may end up with this positioning, but the headlight, which we were going to use, is probably going to be, may have different guts in it. We'll probably just use the lens and build a different kind of a light inside it. How good the fit is when this thing comes down onto the cowl. Still a little adjusting to do, but we're right there at our 1/8 inch. And that's before Bondo. So this headlight in the real world has about that rake to it. And that's not bad. So we might leave it. I'm most proud of the front end work on this truck. This is such a dramatic change. The hood was 10 inches higher. The truck was 7 inches higher. So that hood was about 1.5 feet higher than it is now. And we've made this flow really nicely into quite a sculptured piece. You know, details like this dart, which had to be cut and built all the way to here. You know, this is a nice accent in the piece. The original truck had a shorter bed. We lengthened it this much, 2 feet, but it had this detail right here. We call it sort of like a chair leg or a corbel, little sculptured thing. So we've built extensions of that down to here. You might have noticed when the truck came down, it stopped dead on that. And when we're done, we'll with filler, we'll make this match, this profile match here. perfectly, so it'll just be one leg all the way to the bottom. The fenders have been kicked a little bit. They're pushed out a bit to clear the tires. We had to remake all the bolts and mounting for this. I mean, we had to cut this and lengthen it, and so we've patched it in there. And we've got a little bit of work to do still at the front where this meets the fender. We haven't got our final fender perimeter metal in, so as soon as we do that, as soon as we get this stiffened up, then we're going to extend this running board into this area. If you watch and observe the gap, that's a nearly perfect 1/8 inch all the way around and in metal. That's without any filler of any kind to bring these surfaces together. So when we're done, the only thing that filler might do would be to take one surface adjacent to the other and just level them, you know, like this area right across here. But the gapping all got to be just nearly perfect in metal. The entire frame is really custom fab. We started with what's called a C-channel, and then a piece of steel was welded in here to make it a box. Then all extraneous hardware and bracketing and holes were removed and filled, and this was strengthened and augmented, some cross members put in, and this all designed to fit in here. Store-bought pieces, well, you can buy these bars, you can buy this rear end, but you can't have it installed, you know, store-bought. So this bracketing, this, all of this, of course, the frame, all that made to accept, to receive this store-bought piece right here with this installer provided, but store-bought piece here. All the rest, not store-bought. That you build it every bit of 3 times. Because you're making it up as you go. Certain, you know, there are certain things that you can do per, sometimes been done by other people engineering. But for the most part, you're making it up. Everything you do is its own custom relationship with everything else. So it takes a lot of work. This rear end, I had installed by Scott's Hot Rods. They are very professional at what they do there. They're expensive as the dickens, but they, in my opinion, but they do obviously good work. So they boxed the frame and they created all the mounting and all this stuff. So I never suffered with this other than taking a point on the frame where I wanted this to be, where I wanted the wheels to end up. But I let them do all of that suffering. All the engines, all this, that's all my suffering. You know, every little tab, every bolt, every placement, everything has been done several times over to get it to where it is now. And it's quite good the way it is. So there's more to do here, but this has all been done a dozen times to get it to this stage. Nothing having to do with the engines can be wider than 30 inches because that's the hole between the frames where the bed comes up. So we've really got about a 28 to 30 inch window in which to cram everything, exhaust, wiring, cooling lines, everything. So that's a kind of a challenge. So this Mark Williams 430 gear ratio rear end has a Detroit locker that's a gear ratcheting positraction. Very positive, but it doesn't. It can be clickety noisy sometimes, but it's a great unit. It's based on a Ford 9-inch platform, meaning a Ford 9-inch ring gear series of gears, which are used by nearly every drag racer in the world and every performance car enthusiast for their rear end because it's so strong, is the basis of this rear end. This metallurgical wonder ended up at a 430 ratio because based on the tire size and the transmission that I thought I was going to use, this would get me a pretty good cruising speed. The fact is, I'm going to have so much torque and so much power, this thing doesn't really need that kind of gear ratio, but it'll work out. With an overdrive transmission, it'd be great. With the Power Glide, which does not have an overdrive, I don't know. It'll be under 3,000 RPM on the freeway, probably 2,700. But whatever, who knows? Eventually, I'd like to get it down just for turning less pieces. You don't need to do that. A cruising RPM of 2,200 at 60 or 70 miles an hour, it would be fantastic for this, because then they're just idling along, and you got 1,000 pounds of torque, literally half a ton of torque. I mean, you don't need it. So we'll see. Eventually, I might adjust the gear ratio. But if I get an overdrive transmission, which is the ultimate goal, then I'll be cool. That'll be exactly what I wanted. We've had to do a lot of engineering on this truck. Everything one makes on this truck is in stock. It's just, how do you want it? So we did the running boards, for instance. Just had running boards of a fashion, but now the truck was much longer. And they were flimsy. So we had to add inside the body a 4-inch high steel plate about 3 feet long, another 2-inch steel plate on the outside, weld braces up to another steel plate up inside the floor. Well, some people said I'm out, they laugh and joke, you're absolutely out of your mind building a 3-engine truck. But I said, well, was I out of my mind building an 800 horsepower complete stealth monster, which is what you're looking at right now. You're looking at a 427 Windsor base motor, bored and stroked from 351 to 427 inches, built by Kenny Duttweiler, 8 1/4 to 1 compression, 13 pounds of boost off this Vortec blower through an Edelbrock throttle body. That's not a carburetor, that's actually an injection throttle body, with fuel rails, 60-pound injectors, and an intercooler, which is off the motor at the moment. Right now we're polishing it. Goes right in here with a hat. We've got double alternators, one at the bottom, one up here. Air conditioning, a nearly 9 foot long serpentine belt with idlers and systems, all built by me. Built this plate, built all of this mounting. This is a Vortec setup. We've got a huge 19-inch by 9 K&N filter set down in a cold air box in the fender well, and a wonderful, wonderful Hydro Boost brake system by Power Brake Bob. And so we've made the impossible doable here, and tried to do it as neat as possible. I mean, there comes a point when you can't get it, any better within the price range and the lifetime, but this is pretty good. This is King Kong. It idles very snarly, but 1,000 RPM up drives like butter, and quiet inside. 53/47 weight distribution. That's Ferrari-like. Comfortable, mega stereo system by Rob Anderson, who was an acoustician, but he's also the head engineer of Vortec. He made that blower. And the car's dramatic in its mannerly driving. There's no suffering for the 800 horsepower in this car. This is pretty darn nice. Did all sorts of things in order to accommodate this motor. I joke I should have taken stock in Johnson & Johnson, makers of Vaseline, because I've used a lot of Vaseline on this. Half of it for me with the lousy vendors we had to use, and half for the actual fit of the engine in here. This is quite the shoehorn job. This is a Ford in a Ford, and it's probably the toughest engine swap I've ever done. That's easy. A 3-engine truck is easy compared to this. This car was 22 years. That truck is 7. The truck is coming up on 7 years. Almost 5 of which were wasted on this terrible, terrible thieving body and fender guy whom I prepaid to do all this and who did not. Hence, I am doing it. Hence, I'm very proud of what we're doing because we think we're cavemen beating on metal with rocks compared to what he was supposed to do. And we've actually come up and done good finished work on this truck. And so he had left this thing a mess and hadn't finished it. So we're doing it. And this truck, if a few people step up and if we can get through a few technical issues, this could be done in a year. This could be at SEMA next year. Very realistic. The paint and body won't take long. It's just we got other mechanical stuff. Cooling, AC, Bob, the brakes will be quick for Bob. Full electrical system, the computers, exhaust, stuff. There are many people who had said, oh no, run cable to each motor. I don't think so. I think electronic is the way to go, and I don't see an issue there. But we'll get an answer from GM or Painless or Mallory or whomever. So we've got the connection of the motors handled. Rob Moore at Nitro Driveline is making the two 9-inch axles that connect those CV joints, and that's kind of a specialized deal, but he's going to make those. He's also making the transfer case. That issue's been handled. You've seen what we've done so far. We've done a massive amount of body work, frame, mechanical, engine, and engineering. We've pretty much got a lot of the finish from here stuff planned out, but that would be computers for the engines. We're waiting for an answer from General Motors on whether we can run 3 electronic throttle bodies and computers off 1 gas pedal, that being an electronic gas pedal, as in a diesel or as in most modern cars. So we're waiting to hear from that. Be nice, GM might step up and provide that. That'd be fantastic. So we have that issue. The transfer case is being done probably next week, so that's pretty much a non-issue. We need driveline. We need those 3 drive shafts, the upper and the 2 lower drive shafts. We'd love to have sponsorship for that. That'd be great. The next thing, exhaust, hopefully by Gibson. The electronics, probably a Painless or other similar wiring system, because we're starting from scratch. Headlights and taillights, we've got some custom things being made in the taillight department, but for right now, you've seen what the headlight issue is. We need electronic throttle bodies to control these 3 engines electronically. Right now they're cable and mechanical. Don't want to do that. Upholstery, there's a $10,000 hit. It would be lovely if we could get Gabe's or somebody like that to do the interior.